The final part of topic 4 in the Natural Channels module deals with bedforms. And we see bedforms typically formed in sandbed rivers. They can be sand or gravel, and in fact they're formed on land as well in response to air movement and very similar processes involved with land-based dunes. But we see that the nature of these bedforms that are established within sand beds reflect the hydraulic conditions that they are formed in, and the size of the grains that make up the bed sediments. I want to start by showing you a couple of videos that illustrate or demonstrate the different types of dunes that we can encounter. So in this accelerated video we can see sand dunes forming and moving downstream. The flow is from right to left, and that's the migration direction for the dunes as well. And so sand is eroded from the upstream face of the dune. It passes over the crest of the dune and slides down and deposits on the lee, on the downstream face of the dune here. And so gradually, as the sand grains move from the upstream face to the downstream face, the dune migrates downstream, as we see in this video. And in this video we see evidence of anti-dunes forming. These are waves in the surface of the water are actually anti-dunes, evidence of anti-dunes underneath the waves, and they're moving upstream in this video if you watch carefully. This is actually a dam that's been decommissioned, and there's a lot of sediment in the bed of the dam, and this is the water washing over that sediment deposited in the dam, so it's got a high sediment load, and it's typically the conditions where you'll see anti-dunes forming: high sediment load and high energy stream. There, we're looking downstream through the dam wall. So dunes move downstream, migrate downstream, and these anti-dunes migrate upstream. And that's because the sediments are eroded from the downstream face of the dune and deposited on the upstream face of the next dune downstream. Let's see here, this dune moving steadily upstream, this one coming up here as well. In fact, there's a whole series of bed forms that can be established in sandbed streams, which range from sort of low energy, low flow, what's called the lower regime, up to higher flow, higher energy, the upper regime. At the lower end, we begin with ripples. These are relatively small features, less than 20 centimeters long or so, that form in the bed at these low flow conditions. As flow increases, we get dunes becoming established, and they can be up to tens of meters of long in height in a stream, and have a higher flow resistance too. Manganese is higher with dunes than with ripples. At a height, if we increase flow further, then we get the transition condition, and the dunes become washed out and start to become eroded. They lose, the feature becomes less apparent in the bed of the stream, and then we reach the upper regime. So we've passed through the transition. We get a plain bed, but a relatively flat bed. It's never entirely flat, but certainly flatter than with the other bed form conditions, and then also a flat water surface profile. If we keep increasing it, then we reach this condition where we have anti-dunes and breaking waves in the surface water. And this is showing this sort of transitions from the lower to the upper regime in a diagram. We can see the typical ripple pattern here, and this diagram, this model, characterizes the transitions through to the upper regime based on the Froude number. So remember, Froude number is the ratio of inertia forces to gravity forces, under the definition where Froude number equals the flow velocity divided by the square root of gravity times depth. And so at this low Froude numbers, we get these ripple patterns forming in the bed. As Froude number increases, dunes begin to become established, but we still see these sort of ripple patterns on the face of the dunes. At higher Froude numbers, still less than 1, dunes become well established. And we see sort of boils in the water. We see a dip in the water surface as it goes over the dune as a result of acceleration through here. So we get, through Bernoulli, we get a reduction in the water level. Dunes become washed up out still at higher Froude numbers, and then we reach the plain bed at around about a Froude number of 1, and we quickly transition to standing waves, which are in phase with the dunes on the bed. And then anti-dunes are formed when those waves begin to break, and we get white water forming on the surface water. And then finally, at higher Froude numbers, still much greater than 1, we get this sort of pools and chutes forming in the surface water, with critical flow through these chute sections and a breaking wave in the pool. So that's the model that's used for the evolution of bed forms in a sand bed stream with increasing flow conditions. And the reason why this is important is as you get these transitions between the different bed forms, you also get changes in the Manning's end, the roughness or the flow resistance of the river. And so you can see here for two different sediment sizes, 0.28 millimeters and 0.46 millimeters. Now remember, they are sand size fractions, aren't they? So 0.28 to 0.46 millimeters. We get, as we go from plain bed to ripples to dunes, we get an increase in the Manning's end. It's a range, but it generally increases. The transition as the dunes are drowned out, the Manning's end decreases again, and then above a Froude number of 1, we get some gradually increasing Froude number again with these in the upper regime. So that's all we've got for this topic, topic 4, it deals with sediment characteristics and incipient motion and bed forms. Thank you.